Thank you. Just like to thank the organisers for giving me the opportunity to present this afternoon. So this is the title of my presentation, and what I'd like to do with this is really just introduce what we have done recently on cements, innovative cements in the industry, and a little bit about what we have planned. So just I'll start with a couple of slides on context. Why are we interested in looking at low carbon cements? Well, of course we are interested in looking at low carbon materials, but why ternary cements? And just a little bit of background. The UK cement and concrete industry takes its environmental responsibility very seriously. UK government made some initial but very important steps. These strategies, the industrial decarbonisation strategy and the net zero strategy, were published, and these are helping to deliver on the MPA roadmap. So this is the MPA roadmap, the MPA concrete and cement roadmap. Some of you may be familiar with this. And I'm not going to talk through this waterfall diagram. It's showing how we can get to not net zero, but beyond net zero. So it is quite ambitious. And what I'm going to focus on today is just one part of this, which is on the product level. So cements, what can we do there? And in this roadmap, we have indicated that we can potentially save around 12%. Carbon if we develop the low carbon cements. Another thing I'd like to mention is this low carbon concrete route map. It was published earlier this year, and so for this route map, it was the culmination of 2 years' work. Industry and academia and clients came together and put together this document. And in this document, there's 7 strands. I just highlight here. And in these strands, recommendations are made on each of these areas on how we can get to essentially net zero, really, and what we need to do in each of these areas. So we have setting the benchmark, knowledge transfer, design and specification, supply and construction. So on making concrete, we have optimized existing technology, adopting new technology, and carbon sequestration. Sorry, just went a little bit too quick there. So I'd just like to focus on strand 5, which is optimize existing technology. And in this strand on that route map, we have these sections. And we have quite obvious recommendations, really. Always aim to use a cement type with the lowest possible embodied carbon. And I asked the question earlier, why ternary cements? Well, it's this point here that is very important. Use cementitious materials other than GGBS and fly ash where possible. So, and then of course minimise the cement content. So yeah, just on that middle point, GGBS and fly ash, they're no longer in great supply. We're having to import quite a lot of these materials, and we don't know exactly where we'll be with these materials in say 20, 30, 50 years time. So we do have to look at alternatives to these materials, and that's one of the reasons why we'd like to look at cements with multiple components. And in this on this route map as well, we have some actions at the end of the document, and I've just picked out the ones that are relevant to ternary cement. So encourage the use of carbon reducing SCM, supplementary cementitious materials other than GGBS. That was already mentioned there, and it gets specific there here about ternary and quaternary cements. Increase the use of ternary and quaternary multi-component cements already in current standards. So they're already in standards. That's one thing to point out, and it's going back to the optimize existing technology. We're not inventing anything new here. The problem is we have these technologies already there or in theory, but not adopted in the UK. More common in other parts of Europe, but not in the UK. So already available in the cement standard, that's EN 197 Part 1. I'll mention about another cement standard that was just published last year in the next slide. So it has more ternary cement options in it. So yeah, just the last point, extending the use of limestone powder in cements within the current standards. So that's another option there for us if we're looking at alternative SCMs. Limestone powder is one that we should be looking at, a very low carbon material in plentiful supply. So on to the project that we've just completed. So this is about ternary cements, but specifically ternary cements containing limestone. And on the Venn diagram on the right, hopefully that illustrates what these cements are essentially. So generally or traditionally, what we've been doing in the UK is forming composite cements with fly ash or GGBS, just in the top circle there, and yeah, low carbon cements and fantastic materials, very durable materials. But of course, if supplies of these materials are in question, that's why we want to look at another component. And limestone powder, what we found from the research that we've done and the literature and then the testing that we did is that it's really optimized when it is a third component in a cement blend, not a binary cement, say Portland limestone cement. We've got them, but as a ternary cement with fly ash or GGBS in the blend as well. So yeah, I mentioned about the new cement standard. One of the points here I've noted EN 197 Part 5. That is a new cement standard, and that is focused purely on ternary cements containing limestone, and that new cement standard is all about low clinker, low carbon ternary cement. So it's worth a look at, and that's we picked some cements from that standard and went ahead and did carried out this test program. So the partners are at the bottom. It's a part-funded project by government. Carbon Trust managed it, and MPA, we were the lead. Hansen provided the cements. They blended the cements at their lab in Scunthorpe, optimized, and BRE carried out the concrete testing. So this was all durability focused, this test program, essentially to influence the UK concrete standard, which is a BS 8500. Forterra were involved in the concrete demonstration, so that my first slide there showing the retaining walls, and I'll come to that later in the presentation. So yeah, just another graphic really showing what these cements are. So you've CEM 1. This is what we're used to, CEM 1 plus something like GGBS. Certainly GGBS if we want that very low carbon or high volume CEM 1 replacement. And this is essentially what we're doing here. We're taking some of that GGBS and replacing it with limestone. So it's not more to replace the clinker or the CEM 1, it's saving on your GGBS or fly ash, but I've just used GGBS as the example there. So obviously the big question is carbon. How much carbon can we potentially save with these cements? And sorry, the text is quite small here, but essentially what I'm showing there is we've got the new ternary cements from EN 197 Part 5 at the very end of this graphic, and yeah, we've done some calculations which show that up to 60% CO2 can be saved versus your CEM 1. So quite significant. So just a little bit on the test program. Won't go into too much detail here, but what we had to do at MPA, it's really kind of, there's been no precedent for this, because generally standards really follow practice. You know, that's the way the UK standards have developed, the concrete standard, and you know, devising a test program to influence BS 8500. Yeah, we didn't have much experience of this, so we consulted BSI, the relevant committee. Obviously we had BRE on board, which was really important because they've got some guidance on aggressive ground, in particular alkali silica reaction, And so yeah, we touched all these areas with the test program. So it was 2-year test program. We had 50 concrete mixes, 22 ternary cements, and 3 reference cements. And we looked at 2 grades of concrete, so that brings us up to 50 concrete mixes. So quite extensive, and just looking at applications for people here, I can imagine freeze thaw is something that would be of considerable interest, and of course I'll be sharing my details. If you have any questions about what we did in the testing, do let me know, and I can share some of this, because this is all information that we are sharing. It's for the industry. It's for the development of the standards. So do get in touch if you want any more information. Yeah, just another slide showing what we had to do. We came up with all these compositions. We had to look at different constituents. We looked at variability of different constituents. So this is it's too small to read, but we had to go into a lot of detail on the compositions just to make sure we had everything covered. So essentially, we had cement compositions that where we looked at the variability of the ingredients, and so it meant that in total we had to test 22, which was quite a lot when we had really just 1, 2, 3, 5 different groups of our cement types to look at, but that expanded to 22 because we wanted to look at different constituent materials. So yeah, without going into all the results, there's a lot of data that was produced after the 2 years, but essentially what we have proven after this 2-year program, 3 year after all the reporting was done, that these cements perform just as well as the cements that we are familiar with, and that's composite cements, the reference cements. So the SM3A was one of the references, and SM2BV. Those were the 2 main references that we used in terms of traditional composite cements. And what limestone did, which was really interesting, was it improved the properties of the cements, the concretes that we looked at. And this graphic shows how so this is a strength graph. You probably can't see the detail here, but essentially what I'm showing is we've got our reference group there on the left, which is SM3A concrete, looking at the strength development curve up to 150 days. And we have 2 multi-component cements, ternary cements there in those other 2 groups. And essentially those where we replaced a chunk of the GGBS with limestone, we're just getting the same strength development curves, so it's showing that if you take some GGBS out of there and put in limestone, which is an inert material, it's just finely ground limestone, we get the same performance, so that's really interesting. So yeah, if you'd like to save on GGBS, I'd certainly encourage you to use limestone. So there's clear performance benefits, and we're doing a lot of work on the standards front. So that started quite early in the really from day one of the project. We were engaging with the BSI committee, and there's still work happening. We've presented the results to them, and there's some discussion happening within the technical committee at BSI just on where these cements slot in BSE at 500 in terms of the limiting values, and essentially the same as the references. And freeze thaw, I'll talk about freeze thaw. What we found was, it doesn't matter what your cement type is, as long as you get your air entrainment right, performance is fine. And of course a minimum strength is generally needed. But we didn't find out anything. There were no surprises, put it that way. We knew going into this program that these cements would perform. We just needed that proof, and unfortunately we got that for the BSI committee. So on to the demonstration. With the funding that we got, it was good because they really encouraged us to do a demo, and it was good for publicity, but we also wanted to get value out of it. So we teamed up with HS2 at their the South Portal site in Rickmansworth, and we found a corner of the site, and we ran this trial. So yeah, this is just the construction of these retaining wall sections, but you can see these are just standard sections from is for Terra. They have this standard product, a retaining wall product, and we essentially had 8 different cements that we looked at. We shortlisted 8 cements for this trial. So we wanted to get value out of it in terms of durability. So we got some sulfated London clay, and we backfilled the retaining wall sections with this clay. So sulfate is a key question with limestone. Particularly low temperature sulfate attack is always a concern when there's carbonates in there, and we didn't find any issues with the lab testing that we did on sulfate at BRE, but it's always good to get additional confidence on this, so we just had that opportunity to do that with this trial. And yeah, that's the finished product there. So the other thing is, practically there were no issues at the precast plant formulating these concretes and putting the concrete into the molds. There were little issues here and there that they, if they had more time, they would have optimized the fresh properties a little. But yeah, it's nothing that we wouldn't expect with traditional cements, and that's what we wanted to show as well from doing a trial like this. But you'll see a lot more of these things happening, because the low carbon concrete group that looked after the route map, if we're looking at, say, non-Portland cements, like ASCMs, alkali activated cementitious materials, this type of thing is important for building confidence. It's not just about how the cements concretes perform in the lab, but just some practical issues with placing, manufacture the precast plant. All those kind of things do need to be looked at, if we're looking at new cements for concrete. So just touch very briefly on the next project, which is actually started, and this is focused on calcined clays, but also limestone. So limestone, again, in this project, we're looking at calcined clays, which is potential alternative to GGBS or fly ash, and we've got more partners involved for this project. We got funding from Innovate UK on this, started in January this year, and we're just learning from the experience from the previous project, building on that and taking it forward, and hopefully doing things a little bit more efficiently with this, and as I said, with the previous project, there wasn't much experience about drawing up a test program to influence the standards. So this is very interesting now, and it's progressing very well. We've got a number of clay sources from around the UK that we're looking at, and some showing very good performance. Essentially similar to fly ash, I would say, is calcined clay, and of course, there can be some improvements, or you can optimize a bit better if you put limestone in as a third component in these composite cements. Get in touch if you're interested in this. The other thing is waste brick. So we're covering waste clays, which is essentially overburden material from quarry sites, and there's waste brick, which is already a calcined material. It's been heated, and if you grind up waste brick, you have a pozzolanic material, and so that's showing from the early trials that we've done very good activity and performing very well. So there are these alternative materials, ingredients for cements, and there's quite a bit going on, which is good. And hopefully, later this year, might be a bit ambitious later this year, but next year we'll see a revision to the UK concrete standard, BS 8500, and then the work that we're doing with calcined clays, and we'll hopefully see maybe an amendment or even a revision, say a few years down the line after we get all that data together from that project. So that's it. Yeah, helping us to net zero. Just going back to the slide that I had earlier, it really is focusing on this one bit, but it's obviously there's a very wide range of things that we do need to look at in the cement and concrete industry if we're to get to net zero. But this is what we can do today in terms of our reducing carbon of cements. That's it. So thanks very much for your attention, and any questions?